The reason why I keep like not typing is because I can't follow along.
Okay, so before the break, we were continuing on in our example. We got up to where things are colliding now. There are a couple issues. Is mine still running? Zoom stuff's in the way. It is. Let me close the previous run. And
can you go to the collision area?
So there's a bit of a jump here. There's a couple things causing that. Where we pivot from when we flip makes a difference. And we're flipping and moving before we see it. So it's caused, there's some jumps and there's a size issue that's also related to this other one. And the collision, see it collide with the coin, but it does it when it's way over here. And like when I'm standing on the coin, it might not collide with it. Right? I'm way closer here and it's not colliding.
So it's colliding.
But over here it is. So something's wrong with those collisions. And those are kind of related. So the reason, part of that jump, there's a whole bunch of things going into the reason it jumps there. But part of that big jump is related to those collisions. So let's fix that. And for the other part, you'll want to play around with the numbers, but it's because we do both of these things, right? We flip, then we move, and then way down here, then we see it. So we move, it's moved to a different spot before we see the flip. And also it's not symmetric. So we're flipping from the middle, but on my character here, the head's off to the side. So anytime we flip that, we'll see that jump. There's a few issues. We are very tight on time constraints. So I want to fix the collision bounds there. So first thing we need to do is see them. I'm going to go Google it. Actually, I think it was that page that was open there on the docs. So right, it's like, the bounds seem to be in the wrong spot. So how can we see those so we can debug them? It's kind of hard to debug something when we can't see it, right? See Rec in PyGame. Some sort of search. You all know this process, and always look for the picture documentation first. I've said this before. If that's the user manual, has the whole picture, not just an introduction. If there's updates, the user manual will be updated as well, but old tutorials will not. So the user manual doesn't go out. It's going to be confusing, especially at first. So but use tutorials to learn to read the user manual. Don't use tutorials to learn one line of code. Use tutorials to learn to read the documentation, and then you know how to do the whole thing. After a couple times, so look here first. It's not going to make any sense. Go find a tutorial. Then look back at the documentation and be like, oh, that's what they were talking about. And after a couple times, then you get used to how whoever wrote this documentation, which was probably a programmer and not an English, not a professional writer, they are a professional programmer. You'll get used to how they wrote their sentence, wrote the documentation, it'll make sense. So we see a bunch of stuff about rectangle, scale, flip, update, clamp, clip, all sorts of things we can change on that boundary. Lots and lots of things. I thought there was a fill. Copy, move.
Like a box one.
Update, clamp. I thought there was a fill color here, but I don't see them.
I think it's surface.
It normalize, contains, delay.
I think it's the surface. I don't know.
So you can see there's a lot of different things. We can collide with all sorts of different objects. Rec fill in PyGame.
Is just a surface that's being filled.
Oh, that's a new rectangle. Oh, draw direct. That's what I was thinking of. We have a rectangle so we can
What's the draw?
we can draw that. Maybe I'll just draw PyGame. There we go. Draw a rectangle and then we just pass in the surface and our bounds, it'll tell you what that is, or
So you want to use the image as a surface of the color, right?
yeah. So to see that, see where bounds are down here. Drawing them, you can say PyGame dot draw dot rect, and then pass in our player bounds. This one, the boundary around it.
Surface is what's used.
Oh, our collision area. Everything in PyGame is a surface. Everything that goes on our screen is a surface. We will see that over and over again in game engines. I was going to wait until we get to the third one to mention it, but there is some word that we see unique to every game engine that everything we have to work with is that thing. So in PyGame, it's a surface. And then I think we need a color. 123, 234, 12. Let's see if it like that code or if I should look up how to do that more because I haven't done that in a while.
It's just no, so it's just the thing.
Oh,
It is like the zero.
it should be. That's
And
yeah. I'm used to 3 digits. Oh, no.
I think it's telling us to throw a bathroom watch. It's supposed to be a surface.
This is the one I was trying to do.
Luckily,
Rectangle to draw.
stream one must be hiding that surface.
Did I take it down in my example? Yeah, I did. I'm gonna look that up again.
What I'm saying is it should be the dimension.
Surface,
Because surface is an image of
surface color, and then rectangle. PyGame dot. And this is not what I did last time I did this. There's a rectangle, so there was a way to just draw it.
do you usually make it a variable since it return
PyGame dot draw, which is not what I did last time I did this. Let me try using the player sprite. That's the surface I have. Sprite, do something that's some color. And bounds. And we need to split that on the game. Scene.split. At the spot where we're drawing everything. That's not what I did last time I used PyGame. No, PyGame direct. Okay, maybe if I just do this, it will work. But it's not drawing it. I should have kept it in my I should have kept what I did in the notes. Fill PyGame rectangle.
So can you explain to me what you're trying to do? Because I don't understand.
So we have this rectangle that's invisible right now.
Oh, okay. So are you wanting to draw the?
So our bounds, we're going to see those. I thought there was a dot fill on them.
Color. If you look at PyGame documentation.
Oh, there it is. Surface dot fill. That's what,
Yeah.
I looked at the documentation and didn't see it.
Surface.
Well, let me just try that. Do is take layer dot fill with some color. Let me see if it. I was thinking that's what I did, but it has been like a year since I did it.
I don't think you can put that object there.
Dot fill, it doesn't, it's not looking like it's working, but let's see here.
Yeah, let's say go to
They didn't change it, kept it blank white text.
We have correct. Oh, I need to do this.
Fill.
Oh, you have to put on the screen. Okay.
So I'll keep that color. So do so PyGame. So we do have to draw the rectangle
But it's not the screen.
on the scene. Oh, then color. 1, 2, 3, 2, 3, 4, 12. Then the rectangle we're going to draw. I remember doing that before, but there's a shorter way that is just rectangle dot something. But I haven't done it since last fall when I taught the class. Well,
So,
there we go. So there's rectangle.
That's a pretty large person.
Way bigger than it needs to be, isn't it?
We also need to reveal the coins hitbox.
Yes. So PyGame draw rec, right, and well, that's another good example. I've done this before. I cannot remember what I did last time. I'll do this backwards. 12, 2, 3, 4, 1, 2, 3. Let's see what those colors look like the other way.
I think what you were thinking of is. I think that's what you're thinking of.
Possibly. It was something short that I did last year. And now that I see that, I think that's what I did 2 years ago. That's way bigger than it needs to be too. So it looks like they collide at the right spot, but they're way bigger than they need to be. So I'm gonna take this line, hit cut, and put it before the character so we can see how far off it is. Highlight that line and cut it, and draw that bounding box before we see the character.
What the?
Huh.
That's huge. So we need to set some coordinates on that. So I think a rectangle is up here, isn't it? There it is. So when we create a rectangle, we should be able to pass in size. Like, or inflate, grow or shrink the rectangle size. That's probably the one we want. Probably want to do that right at the beginning, right? So it created a rectangle and it just, I guess we just left it to the computer to decide how big that rectangle should be, and computers are not intelligent. So let's try player bounds. And again, with the documentation, inflate, grow or shrink. We just,
Maybe in that get rect
oh, this
parentheses.
one. And notice it returns a rectangle, so we have to save it somewhere. So
What about you have the parentheses after the
oh yeah, that would work too.
when you're creating the bound, Could you just enter like player dot sprite get rec and then put a size in there?
Mm.
Would that not?
That would work. I wanted to take a moment to look at the documentation. To remind y'all about that we have a list, we have a user manual. But yes, that would work. There's lots of ways to do it. So he was saying put our size here, 64 by 128. Which I think we need 2 more numbers there. We need width and height and all that, but it takes 4 numbers, but I wanted to look at the documentation. So with the inflate method, it takes in an X and a Y, the size we want, and returns a rectangle.
64 by 64.
64 by 128 is the size. But then it returns a rectangle, so we need to replace the original one with that inflated one. We get something back, so we need to do the assignment. It doesn't just carry. We have to save this change.
Bare bones.
Give it a check, see if that worked. Oh, previous one's still running. Close that. Now give it a check and see if it works. So, yes. So it's get the name of the method, inflate. So we just multiplied by that much. So we need to.
Define.
Is there a deflate method? There's a new rectangle changed by the given offset. Then it's correct thinking. Negative value with shrink and
Is that yours too? So you want to make it negative values.
or scale by
No.
rectangle size.
I mean,
Is there just a new size?
one rectangle.
With cross rectangle inside another.
So technically, you could use the transform scale by whatever you used earlier. I think.
Yeah, scale would work. Lots of different ways to do all this. Resize the rectangle is normalized, contained, collide. Then we're down to collisions.
I think it says something about using negative values. So maybe.
Yeah, let me try this real quick. What he was saying. 64, 128. Let's see if 2 numbers work for that.
It spit it out.
Doesn't like it.
I was about that, so the transform scale.
So
You can use negative, yeah, let's say you can use negative values there.
so I think that's gonna end up too small. Let's see what it looks like. It made it. It divides by.
Yeah.
If we divide by 2 ways, let's see what this gives us. And you might just have to try a couple numbers to find the one that works.
Negative 40.
-4, -4, probably more than that still.
Good testing.
That doesn't look like it changed it.
60.
Resize and move a rectangle with aspect ratio. Smaller. Whether or not just a size. Wouldn't that be easier? Update scale.
If we could, I'm trying to find the get rec, because there's definitely stuff that goes in there, and I'm seeing some stuff on that, but
So maybe inflate. Let's try scale by. Scale by. You don't know this process. I was
Oh,
gonna.
that was worse.
So the 4 probably want to 1/4. 1/4.
Is it integers or float?
I think scale will allow either one.
Oh, there we go.
That looks a little bit better, except when we do this. So now we see, now you see where that flip's coming from. Because the rectangle stayed in the same spot. But our character is way off when we turn to the left. And when we turn back to the right, it goes back to there. So we need to flip and move. What does that look like? So it's 64 pixels wide. Looks like it need to move 128 pixels over.
Because it's 64, and then it's 64 this way, right? Okay, so you can always do right?
Yes. So really what happened here is it flipped over this line right here. So that put us 128 pixels over. Which is, that's, make sure you do that whenever you hit a bug. Like here we can see it can move 128, need to move 128 pixels over. But try to take a moment to figure out why it happened. Even if you see the obvious answer, it's like, why was it doing that? That was unexpected. So I guess we need to scale this as well. Nugget bounds equals nugget bounds. Dot scale by 1/4, 2/4, or 0.25, however you want to do it. My mind works better with fractions. Let's see.
Because, you know,
Looks like it's about the right size, right?
Yeah.
So the bounds look good now, and we can see, and then that flip thing, whenever we flip, so if we turn left, then we need to go player chords is our X coordinate. So player chords 0. Okay. We only need to change the X coordinate, right? So our X coordinate is going to be whatever our X coordinate was. I think we need to go minus this time, right? Minus 128.
get it all.
Oh, I don't know why I had to click that.
Did you say that?
Oh, yeah.
I think it's saved.
It's saved. Player chords equals player chords. Why did that not move? Minus equals 128. And then the other should be plus equals. Definitely saved now.
Let's get a little closer there. Maybe. But it's not going in the other direction.
Why did that not move? That one really shouldn't. So we turn and then we do this.
Because, yeah, you got player chords minus equals player speed. I think that's what it's
Oh,
talking
well, that's our actual movement.
about. But aren't you repeating it twice?
Sorry to interrupt here. I figured out how to do it in get wrecked.
What was it?
Inside the parentheses, you need size, space, equal, and then your dimension. So like I did 2020 for my nuggets, a little bit too big, but yeah.
Okay. Oh,
It's literally just size, space, equal, space, and then parentheses.
Did you all on the Zoom call here, Brady? If you want to do it in one line, there's multiple ways to do it. Why is it? Oh, this way. So it works when we're on the right. So our player sprite is offset. The coordinates are good because the box is showing up in the right spot, but the image is off. So we need
Is that rectangle being updated? Is that?
This go. The rectangle is on the player coordinates.
So
Oh, yeah.
the rectangle is where the player technically is. It's just our sprite image is not where it is.
Yes, the image is in the wrong spot. I wanted to be at this point by 3 o'clock so that we can do our cutscenes. So I'm just going to do a quick workaround here. We already have a Boolean here, right? We know whether we're moving left or right. So if we're moving left, so one quick workaround might be like here when we go to show the character, if player left, then we want to do this. Very cool. Player coordinates 0 decreases by 128. Let's see if that works. Else, we just do it without the decrease. Let's see if putting that number here works.
I think it's because you didn't add it, maybe.
Okay, that was that workaround didn't work. Okay, well,
I'm proposing on the way you could do a workaround would be have 2 images, one of them facing left, and just if left is true, show the left face. If left is false, show the right facing one.
that works. Having 2 images blows everything down though. So I'll leave that one for y'all to find a workaround because I don't want to spend any more time in class digging through looking for it. The boundary's in the right spot, so things are interacting correctly, right?
More or less.
So now we need the other part of the game. I'll just leave those boxes on there and we can see where it actually happens. That storyline, right? We wanted to do a story to make it interesting. So I'm just going to go create a new image to add here. It's a new image. And this needs something for our maze, so I grabbed the pencil. And for now, I'll just draw something that looks like the Rocky Mountains. On our way across the country, we have to go across these big mountains.
Maybe hit the black.
What's that?
Maybe I hit the black with it because maybe.
Yeah, we'd probably do more on the image, some like snow caps and stuff, but we're running short on time. I wanted to try to finish by 3:30 today, so y'all have time to do stuff because, well, play around with numbers, see if you can figure out what that one is. I've gone way off what I prepared for, so I would have to spend a long time digging. I have to spend a long time digging through examples to try to figure out. Oh, not examples. I've gone way off my example, so I might need to spend a long time digging through the whole code again to figure out why that's not working like I expected. Something got off. But this should probably be, again, up in the corner of this 0, 0, and 64 by 64. Sound like a good size for our mountains. Well, these are going to have a boundary and block us from getting across. Eventually be like a maze where we have to find our way through the mountains. Yes. I make it the same size as the character.
At this point, what makes the character that's tall to mountain.
It'll work.
Okay.
It'll work for now. We just need to give the impression. So you can do some adjustment, but the same size as the character will make it it makes it easier to work with things. So it's kind of like a wall, but it just looks like a mountain. And I'm just going to randomly place them. So again, reset the size, then save this, and we'll just kind of randomly place them so there's a different route every time. Which will probably also give us a good chance to see the downside of completely randomly doing things. Actually, I don't want to completely randomly do stuff. It's a lot better to do probabilities, kind of like you'd see in a D&D game. That's a good way to think of it. Set up your probabilities like rolling the dice. Roll a natural 20 and yeah, and set up your conditions that way to randomize things, and then it's not quite so random. What is this? This is mountain. SVG, and then a bunch of stuff we've already seen, right? We'll come back up here and mountains. Mountains bright. Sorry. I'm going to make a list of these. So I'm going to make just call it mountains. And I'm going to make a list so that there's like 5 of them. The reason I'm doing this is so that it'll preload 5 images in. The same 5 images, because I want each one to be pygame.image.load images / mountains. SVG is only mountain.svg. And then I'm going to copy that. So I just made a list of the same 5 things. So if it helps to relate to numbers, think of a list that has 1, 1, 1, 1, 1. Right? We can put the same number in the list more than once. But that will cause the computer to preload them at the beginning of the game instead of trying to reload 5 images every time we go through the loop. Because the second one is a lot slower.
Do you want the comment at the end of the first one?
Yes, I meant to copy the comment.
Okay.
It's a list. So really that should be one
Here's the
line.
list. Okay.
But I forgot to type the comment. Think of it as you've seen numbers, so we put the same number in every spot in that list. And now it loads all 5 of them. It loads it 5 times in initialization instead of trying to load it 5 times in that one frame of a game.
How do you make it start in separate spots?
I was going to use another list.
Okay.
Location is another list, and each one needs to be a set of XY coordinates, right?
It still has to be the map.
I'll import random. That'll work. And then we can do random dot all the languages are blending together. Is it random dot next int? No, that's Java. Random dot my programming languages are blended together.
I was going to say C, but that's definitely
Random int Java. Python.
Okay.
Java's the one I remember. That was the problem. Oh, rand int. So rand int, and then there's values in there. So we'll say rand int between 3 and 9, or in our case, a couple of numbers that would make sense. We can use where the gold nuggets at and where our players at to try and on down on where they should be. That's ranging. It's a range. But if you leave it blank, it just gives you a random number. But if you put in two numbers, so say our score, we want it below the score, right? Our score is 30 Y down and 300 over. Probably a little before the score, so somewhere between the nugget is at, where's the nugget? Wait a minute, I did this in the wrong spot. I'm sorry. All of this
You can't define
is in initial, we're like up here in initialization.
that.
This is unindented. Unindented. There we go. Random int between where the gold nugget is, so 40 over. Split the mountains past that, so maybe 65. And our score was 30 down plus 30 pixels tall, so maybe between 65, this is the X value, 65 and where's our character start at? Our character starts 723 over, so maybe 345. I'm just gonna guess that. The same thing with the Y. Random dot some random integer between the score is 30 down, 30 pixels tall. I'll go a little bit past that, so maybe 70 down. And I guess our whole screen, or almost the end of the screen, 400. So some random XY coordinate. And we don't want the mountains moving, right?
We really weird about.
Yes. Well, that might be neat in the game, but we, for our case, we want them to generate and then they stay there like a maze. And now we'll come down here and just loop through those when we're doing our putting stuff on the screen. So the background, the player, the nugget, maybe up here. I guess it won't really matter because we'll add some collision bounds so that we bump into it. Or we're getting very tight on time. So y'all have seen how to do collision bounds, right? We don't necessarily need to do that. We'll just try to avoid the mountains while we're working because we're running out of time. And then we can just loop through there. So for M in mountains, we want to do scene.blit. Whatever one we're looking at, you know what? I need to do range. Because there's two arrays. And most of y'all probably haven't seen multiple indexes here, right? So let me do I for index in the range of that list. Then we want to blit mountains index I, and we want it to go to the respective coordinates. What do I call it? Location? Yeah. Location index I is the one that should correspond to that same mountain. Does that make sense now that we see where it's going to? How we have those two parallel arrays? That's one of the things in SDEV 120 that y'all, I think everybody had seen that. The people that said they hadn't seen it, I knew have seen some programming before. So we have two arrays where our indexes line up. We probably also really want a third array that has the bounds that we could use that way. Or for those who have seen it, object-oriented programming. This object cannot be interpreted. Oh, that's another list. So, what?
I think half the time we're saying.
Oh, length of mountains.
Okay.
Sorry. hopefully that's something everybody's seen before, right? We don't want the list, we need the range on how long the list is. If not, yeah. Okay, so they're scattered around, but now
Clear in the ocean.
we're running out of time, but we could go over here. It's really the yellow box we have to worry about and go between there and get to that. Yeah, but we could, and next time we run the game, we'll get some random generation. So our lower bound is definitely way too low. I think our upper bound is probably too high. Our bounds are a little off, so let's go adjust those. So we don't need to go to 400. Let's go to 200. And oh no, let's put 20 here. And then I'm going to stop messing with numbers so we can move on to the next part. That makes it. There we go. So now they're all in one spot, and it's kind of like a maze. What's in the thing here? Some sort of gameplay, right? There's something stopping us from getting across the country. And I'm sure you all come up with all sorts of other things. We've seen collisions, we've seen how to make things collide. The same way we grab the nugget, you do that on the mountains, and then it stops us from moving that direction. All you have to do is, for that case, is
While collision can't move
yeah, set a exactly. That's a great way to do it. Set a boolean so that you can only move when not colliding with a mountain. All sorts of other things. You could add in some rattlesnakes so that if you hit a encounter a rattlesnake, the character automatically dies. Or in 1849, there were a lot of other predators too. Wolves, when you get out in California, cougars, and mountain lions.
Can I see the location thing?
So that got our maze, that got our gameplay, but then the storytelling aspect, right? That's Act 2. It's like The Empire Strikes Back, and we left off New Hope and Return of the Jedi. All we have is that conflict, the interesting part. We need to introduce our characters, and we need to resolve things at the end. So I'm going to do a quick animation. And I'm going to send this as soon as our lecture ends. I'm hoping to end in about the next 15 minutes, but animations are really easy. Well, ish. We're not going to do every frame of the animation. I'm just going to throw some stuff up there. So first off, we have this one infinite loop, and we'll need to use this one infinite loop, right? But we have multiple things we need to do. So I'm going to do is take everything that's in this loop. I'm going to highlight it all the way down to the end of the main loop. Actually, I could probably leave those last two things. Let me unselect those, because update the display and tick the clock. That's going to happen on all of our scenes, but everything else is unique to the gameplay, right? We don't need that stuff in our cutscene. So I'm going to copy that. I'll push Control T so it's on the clipboard now, and move that out of there. And then somewhere up here, before we get to that loop, I'm going to define a function that says a gameplay. Gameplay, and then paste it in here. So now, to get the same thing, I can just ask for the function. So in our main loop, make sure we do it before we update the scene, and say, we can call that function. All those instructions are just somewhere else. So now we have an option on what we do in our main loop. That'll be important for the cutscenes. Uh-oh.
Oh, it's because of those things you develop. So,
Yes. So these all need to be global.
Yeah.
Global next scene. So this is a basic Python error, not a game error. If you haven't seen this before, just making sure that we use the move counter, scene left, This one. And this one, I think there's one more. So just the keyword global, and then you could put global next to each one on individual lines, or you can just do a big comment separated line. All the variables we want to be able to access. That basically name. Yeah. There's also that player, which I guess I could have just typed that. Player left and player speed also change. Any variable that's going to change we have to set it up to be ready to change. So player left.
You don't need all the other player stuff that you're missing, because that's where all your movement is.
But they won't be changing. The only thing that changes is our coordinates. So which way we're facing and our coordinates are the only things we're changing. So just player left and player coords. And then I'm going to add a comment so we can tell where the end of that is, because it's Python, so it's all white space. There we go. In gameplay function. That way we can tell where the end of that is. White space makes it hard to tell. Hopefully that got all of them.
Player spray, all of that, yeah.
Makes sense. Okay.
You need everything in there.
So another thing we can do
Is there an easier way than having to just copy and paste all of that in?
probably not. We'd have to create it there.
If you
We need all of those. So paste it here. And it makes it and underneath that variable. Next one's player coordinates. That's already on there. Then player speed.
Can you not declare that they're global back when you were setting them earlier or something? Or?
It has to be in the function.
Yeah, they don't communicate with unless it's in the function. Like basically, it has to be defined in there with that defined.
There's all the player ones.
That's a rule.
Yeah, you're probably also gonna need stuff for the nugget
Yes.
too.
Let me move. You can read it. It doesn't necessarily have to be in one line. If there's just a few, it's nice in one line. And the nugget stuff, right? Global. So these things aren't changing, so I was not expecting that to block us. We can use stuff that's not global unless they've updated that.
Maybe it just doesn't want you to use them unless they're there. You have to declare everything, maybe not. It's not changing, the sprite doesn't change ever.
Yeah, so we should only have to do this for things that change, but
It still is screaming about the same thing it needs the sprite. So I guess any variable that appears in that code it needs. Just in case, I guess.
I think we still need score.
You need everything. That is literally containing every single variable we have. That's our main code.
Okay, there we go. Now it's back in there. And it still works exactly like it did. We're just calling that function and then it runs through one time. And we just ask for that every time it loops, and now we can ask for different things. And quickly throw together a cutscene. I'll do an intro cutscene.
I think you made the wall true, and it's not gonna do anything, so it's not gonna be stuck.
What's that?
It's gonna be stuck now because you have the wall true. Nothing in it. I think, where did it comes. Like, if you go to the very bottom, it's-
Why didn't it stop
It's still going.
while playing? Oh,
Yeah.
when you're playing variable, which has to be created before then.
also have your bounces.
Which one?
These two.
You put million.
That won't hurt.
No.
That would work. There's our gameplay, and we can hit the X to close. We should probably let's do a quick intro cutscene, and it might take a little bit past 3:30. I was hoping to end by 3:30, but this is going to be really, really quick. Because my thought for introducing that, right? It's like the 1849 gold rush, so we can just draw like some old timey newsboy would be the word for it, which we can just use our character to do that. So let me go to the character, copy the character, and rename this like newsboy, and just some quick edits. Yes. So we go over here. I gave him a different color shirt. Boys in a green shirt. That'll work. And then we use hats, what you're called. Okay. Actually, those always seem brown or flat, don't they? That looks very wrong now. That's a green one. So there's our newsboy. Oh, he probably needs a paper. So paper, something paper color, and then I'll just draw some black lines on it. Don't fill and stroke. There we go. There's a newspaper, and we can just put words on the screen like "Gold discovered in California" or something. Something to introduce the story. Let me grab all of these. Or I could just. Oh, so we just quickly edited the character to an old timey newsboy, so that it introduces the story of the gold rush. Oh, yeah, adults rarely sold newspapers back in the day, right? Or if they did, we don't see them in Hollywood's portrayal of them, so it's going to look wrong to a modern American. So should probably make him a little shorter. So instead of switch this back to 64, and instead of 128, 70, a little more than half of that. And maybe get it where it all fits in there, something like that. The rough idea, right? It's not the final version, but that storytelling is important. So now we know where our character's trying to go. And to do that, we can throw it on the scene the same way. We're not doing new things here, so define intro cutscene. We need a bunch of stuff, but I'm just going to copy this global. I don't think we need all of this, but I'm going to go ahead and copy all of it. Because if we don't need it, it won't hurt to have it there. Then we don't have to stop and think about it right now and burn up all our time in class. I was hoping to be done by 3:30, but we're really, really close now. We just need to finish this animation. So we need that newsboy. So we're not going to move him or anything. He's just for a quick animation. So I'm going to come up here. Newsboy sprite is PyGame.image.load images / newsboy. Is that what I called it? Newsboy, yeah. Newsboy.svg. And I'll just hard code the coordinates in later. We're not going to edit them, so we don't. It's not going to move for the cartoon. We're just going to draw them up there. But we apparently need this right there. Actually, we could have created this one. We don't need that one global. He's only gonna be there in the intro one. So we'll put him on the scene.blit, newsboy sprite, somewhere in the left of the screen. Uh, 180 over and 222 down. I'm just guessing some random numbers there. Maybe put a background here. What did we do to fill the background earlier? We just used fill, right? The one that's commented out. Scene.fill, yeah. Scene.fill. Actually, I should just copy that line. That'll work through the background here. Here was that random green color we had at one point. And a bunch of jumping back and forth, and this is probably looking confusing, right? Had that in mind because that's going to make what we start into next week look even nicer. Next week it's all a GUI. We're not writing code. It's very nicely labeled, and people have spent like decades going back and forth on the icons, so we don't even really need the labels with the one we get into next week. So we put a background, our newsboy on there, then our character, scene.blit, player sprite over not far from that newsboy, so maybe 456 units over and 280 units down. Close enough he could hear him yell, and then we'll put those words up there. So announcement is that score font dot render everybody's familiar with American history, right? So that famous point in history, gold discovered in California. No, we don't want anti-aliasing. And then what color do we want? Probably same color work. Same one we used for the words last time. And then we can scene.blit the announcement. Not the font like I did last time. The thing we made from the font. And I guess really it'd be nice to draw a speech bubble here and stuff, right? But let's get this whole speech bubble thing and just give it some coordinates up near the top. So 250 over, so that it maybe 180 over, right above the newsboy and not as far down. So 222, so 170. It'll look like it's right above his head, but in in the long term, when we have more time, we probably want to draw a nice looking speech bubble or something. Looks appropriately, and we'll just throw that on there. And then the last thing that I wanted to show, an ending cutscene would be the same, but we need to decide when to go between our scenes. This is the last thing I wanted to show. So intro cut scene. And I did ask for like an introduction or closing cutscene for your for the tutorial. Those weren't included in the tutorial, so you want to add something like this. So now we have a choice to make. So we have two scenes. So I'm just going to do it as, I'll just do it as string. So current scene is going to be intro, because that's where we start at. And if current scene is equal to intro, that's when we wanted to call the intro cutscene. Otherwise, I'll do it as an elif. Elif current scene is equal to gameplay. Play. Sounds like a good one. That's when we're going to do this, and then so on and so forth for all our scenes. So now we just need to know when to change it. Let's give it a check and see if that one worked, because it wasn't a bit of a rush there. There we go. So, guy, here's the announcement. Gold discovered in California, and that motivates the reason we're playing the game, right? Anybody familiar with American history is going to know, okay, that means get across America in 1849, like the classic Oregon Trail game. So there's lots and lots of, anybody's like heard of that game or remember that game?
That's why I was going to joke.
Oh, we don't have any events programmed in. We need to copy the events over.
In fact, it's completely locked up.
Which happens, but actually we don't need the movement events. We just need to copy over the quit event, right? That's the only thing that could happen here. Is we could quit the game or watch the scene. And what we need to do is set up some sort of timer. Any game engine we have is going to have a timer built in. They're in all of them. Over the years of doing this, I told you all when I made my first video game, right? First one I called a video game. We wouldn't call it that today. Stickman, dribble a basketball and do that through a circle. It took me all summer, but it was done from scratch by memory. I'm still proud of that thing. There was no Google. There was no looking it up. I had to do it all by trial and error. and remember a programming course I took a couple years earlier. I'm still proud of that. 30, almost 40 years later now. No, it's not almost 40. 33 years later now, I'm still proud of that thing. We wouldn't call it a game today, but and since then, I've enjoyed doing this, done it regularly and done it quite a bit. This is just a tip that I've learned over the years. There's a timer built into all our game engines, but there's a better way to do it. So what I do, I've learned is to set up a frame counter. Frame counter equals 0. One counter. We don't need a frame counter for our newsboy animation, a frame counter for our rattlesnake animation, a frame counter for our gold thing spinning. We can use the same counter for everything. Because then we go through our loop and we'll just increment that every time. Frame counter increments by 1. And then whatever we want to do, we can use that frame counter in order to do it. So after we update our display, I want to check the state of that frame counter. So like if frame counter, how long should we stay on that and opening cutscene? There's no animation, but maybe 3 seconds if there was animation. Does that sound good? 3 seconds would be approximately 180 frames. So if we take frame counter mod 180 and there's no remainder,
What in the hell?
You all seen modulus operator?
It's like a division, but then you have a.
Divide and we get only the remainder. So if we divide by 180 and there's no remainder, which the first place that happens is on after 180 frames, right? Then we know 30 seconds have passed, or about 30 seconds.
Okay.
And as opposed to using the internal timers, this is why I found this can be better. Our frame rates are not consistent. Then we can time things based off the frames of the game, because that's what we're thinking about the whole time. Right? We're thinking about the frame of the game, frame of the game, frame of the game. Then trying to go to a normal clock after all of that, we might get alter times. So we use the modulus operator to tell how many have passed. So if our frame counter mod 180, we divide by 180 and have a remainder of 0. That means 180 frames have passed, and current scene is equal to intro. Then we know we're ready to move on to the next one. Right? So set current scene equal to play. And when we come back around, it should load in the play scene instead of that one. And then we can do all sorts of, then we can keep using that counter, right? If there's a timeout, right? Elif frame counter, we don't have this one, but maybe we give the player 10 seconds. So 780, if we have no remainder when we divide by 780, then that means 10 seconds. The first 180 plus the next 600 frames.
I'm just wondering why we're using the different.
Because we would have to reset it. So we can do that, but we would have multiple things. So maybe there's an animation here. So at 180, we want something else to happen. We can keep doing things. We can let the number go forever.
Yeah.
Because eventually it'll hit an overflow error. And when we hit an overflow error, it goes to our largest integer, which the way they're set up is the pattern will continue. So it'll just go forever. If we reset it, we have to, I've done that before, resetting it and use an equal to a certain number of frames. We have to keep resetting it and keep track of what it is. If we just let it run forever and just think about how many we need. You can try different ways.
I still don't understand why that doesn't work, but okay.
Oh, it will.
Okay.
So we could say when the frame counter is 180, we do this.
Okay.
But sometimes we don't want equal to. We want greater than or less than. So try different things. So this is my recommendation after decades of doing this. Use one counter and use the modulus operator. But what you're saying will work.
Okay, I was just confused as to what the different, like, yeah.
This is the one that allows it to run forever.
Okay.
And we can come back and forth.
And why wouldn't the other one? Because wouldn't both of them, they both
It would, okay, I guess another situation is maybe instead of intro, this is level 1 and level 2. And we can go back and forth between level 1 and level 2. So we play through level 1, then we go to level 2 when it's equal to 180 frames per second. But then if we go back to level 1 for some reason, how do we get back to 180 frames per second if we've already passed that? Does that situation make sense?
Yeah.
Because if we use
Yeah.
the modulus, then when we go back to level 1, we can let another 180 frames per second pass, another 180 frames pass, and we'll hit another number that's divisible by 180. These keep happening over and over again. Equality only happens once.
Okay, so that's when it's evenly divisible by 180.
Yeah, which happens every 180 frames.
Yeah.
So then we can go back and forth. And we don't have to, the problem I had when I was using equality was I had to stop and think about when the frame counter needed reset and when it didn't. And it added a bunch of extra steps. But there's multiple ways to do it. Obviously, you're going to want to spend some time making games. An outro cutscene would be about the same, right? I guess in our case, what I was going to do, I was hoping to end by 3:30, and it's already 15 minutes past that. I was just going to lay the character down and say you died, or show the character, copy and paste the character, and they go celebrating or something. From what we've seen, y'all should know enough to be able to make that. And it would happen where currently where our score is incremented. So it looks like we went to the next scene. We do that again. I was talking, so.
It's way too fast. I saw it for a blip.
Frame counter goes up by 1 each frame. Start entering.
I saw a brief flash of the other color. So I think it's just the frames are going by so fast. It's
Pick that change up. I'm just going to highlight this, get that. So now it should only do the first one. There it is. So yeah, it's going there too quickly.
like, yeah, I saw a brief flash of it when you open up the thing, so that working is just way too fast.
Oh, 60 frames per second. Or is that 6? Is that doing 60 milliseconds? No, 60 milliseconds would be way too quick. Let me just try a bigger number. So trial and error. Let's try 450. The frame. Oh, I know what it is. No matter what number we put in here, I've made this mistake many, many times. Didn't even think about it now. Our first frame is 0. What's 0 divided by 180?
Oh, 0.
With no remainder, right?
Right.
So let's start our frame counter at 1. And I can't not even tell you all how many times I have made that mistake. You just did it again today. Nah, there we go.
Yeah.
So watch out for things like that. And now we can play our game. A rattlesnake that moves through the maze would be a good one here, right? And yeah, and then set up the collision to go to another cutscene. So the ELF here, the frame counter mod 180 is equal to 0 and cutscene equals intro, then go to play. ELF, the collision happens, so we might want to set our collision up here somewhere. That's something for y'all to try, right? We learn by trial and error too. My recommendation is try to give it at least 3 tries and then look it up. Right? Don't waste forever looking it up. I'm very proud of that one I did my first game, but looking it up was not an option back then. I was 13 years old on a farm that wasn't a farm anymore. There wasn't a whole lot of things to do. That was very helpful for learning things, but give it like 3 tries. That's enough to do the trial and error. If you can't get it in 3 tries, then look it up. Because we get better by trying things. There's plenty of extensions that can be made on that, right? You can do a cutscene, add some more enemies, maybe run into the mountain so you stop moving. We've seen all the pieces here, and that's what I wanted to end with. Most of the main pieces of a thing. We didn't see the sounds on here. I didn't do sound, but and again, we loaded in PyGame.sound.load. It's almost like an image. And then there's a .play, .stop. Actually, those are the 2 we would use. There's a bunch of other ones, but it loads in that it looks almost exactly like the way we loaded images in, except it's a sound, not an image. Just point to your sound file. And then there's a dot play method and a dot stop method. Those are the two you would probably use. But I have this list, the things we want to learn as soon as possible on a game engine. Lots and lots of functions in there. Transform data, that word's going to be important. We'll talk about it next week. But transform is location, rotation, and scaling. That's a big part of physics. Where is it located? How is it oriented? And how big is it scale? You'll probably notice there that that's what we have control over. That's how we control our game. That is the vast majority of game development is controlling that transform. And making sure the graphical transform is lined up with the processing transform. Because they're two separate things, right? We saw it with the box. The bounds and the graphics were not lined up. So we need to make sure our transform data is correct and lined up. So obviously that's the first thing you always want to learn. Animations in PyGame, we have that frame counter, so you would just use that frame counter to control which one it is. That's another reason why I use that, and then I can use the same counter for different animations. So like frame counter mod 20 for the player animation, and frame counter mod 5 for the 5 frames in the rattlesnake animation. And then we don't need different ones, and we don't have to reset it every time. You can use the same one over and over again. Sound is just like images, and then dot play and dot stop. We didn't really see that in PyGame, but PyGame was just the introductory thing here. Then you want to figure out what you need to do a heads-up display. One thing I often do with a new game engine, first thing I'll do is make some business software. Things like you would see in basic programming courses, interest rate calculators, or interest calculators and payroll calculators, and do those things, but make a GUI with the HUD components for your game engine. It's a good way to learn to use those and get used to the syntax for the game engine. But you want to make that HUD pretty quick. You're going to need to get some information to the user that's not in the graphics. Numbers and words and something beyond the graphics. I think everybody knows what a HUD is. Heads up display. Our control events, whether it's keyboard, mouse, joystick, etc. How do we do the events? We saw key presses. That's not the only ones. We can set PyGame up for joysticks and stuff. How do we do collisions? We saw those. And how do we set up timer events? So my recommendation is the frame counter. My recommendation for what not to do is don't use sleep or delay. I never use that. I never use those because if you use sleep or delay, your program stops processing. That's a very dangerous thing. If you want to use those, what's much better is just to take the timestamp and then keep checking the timestamp until a certain amount of time has passed. So then you never stop processing, because if you stop processing, you're out of control for a moment. It's not going to be like what you thought. What I found over the decades is the frame counter works good. But those 1, 2, 3, 4, 5, 6, 7. That's what you want to learn as soon as possible when you're exposed to a new game engine. Transform data, location, rotation, and scale. And we're going to keep talking about transforms over and over and over again. I just wanted to wait till we'd seen at least one example before we talk. Animation. Sound, which we ran out of time for in PyGame, but is really, really easy. Our heads-up display. Whereas we saw a score, but there's usually a lot more going on. Control events, collision events, and timer events. These are the things to learn as soon as possible when you get to a new game engine. You don't want to take a picture of that keep that in mind or remember the notes. I'm gonna read off this list again before the semester's out. I'm pretty sure I am. But we saw a bunch of those in PyGame. We had to skip over sound, but sound is exactly like our images. Animation / images, because we might have still images. And our time constraints, all we had time for here was still images. But that wraps up the PyGame coverage. Next up is Game Maker. Y'all will really like Game Maker. Almost everybody that opens Game Maker really, really likes Game Maker. We don't have to know the language. We're not jumping back and forth in the code and using pre-built methods that somebody else made up the name for. In the case of PyGame, several people made up the name for it and they didn't even spell it consistently. So we will be using, it's all in graphical interface. It's well labeled and really nice icons. Most people find it quite intuitive. I used it in a game development class. I was a student at Tech and well, and I installed it about a week before class started because it came with the textbook. And before class started, I made an overhead map, a huge overhead map that the character would wander around and periodically would jump to a side fight scene. And I did that before class started, just from looking at Game Maker and be like, oh, this looks easy. So that's the one we're going to go to next. Yep. It's like, oh, I can tell what this icon is. These labels are very obvious. So that's the one we're going to go to next. Most people really, really like it. It's a 2D thing. So it's for 2D games, but it's very popular. So you'll want to get that installed before class on Monday. I'll send an announcement to remind it. Otherwise, finish up the PyGame tutorials. Those are due Monday 9th. And Monday in class, we will be moving on to the next section.
And the thing we come to the tutorials is something akin to that, but with your own spin, right?
Yes, put your own spin on it. I would recommend like the storytelling cutscene things, whatever you can fit in time. I understand it's very time consuming, so if you can't do much of your own spin, perfectly following the tutorial will get you a B. So
And more
your own graphics. They do not have to be good graphics. If all you can do is a stickman that draws stickman, as long as it's your own stickman, then that's a great one for practice. Things improve with practice. So I'm getting the practice. So some of your own graphics, no quality. I know you gotta go. No quality restrictions on those, but some of your own customizations. Try to get those in as many as you can. We are in tight time constraints, so I am very understanding. Hopefully by now you've noticed I'm a pretty laid back person. If you have any problems, let me know. I have all day meetings for the next 2 days. But then on the weekend, my schedule is open, so I'll be able to jump on a Zoom call pretty quick then. Y'all have a great one. I will see you on Monday.